Next, NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again.
NASA's Voyager 1.
For nearly half a century, Voyager 1 has sailed through the silent abyss of space, a solitary emissary of humanity, drifting farther than any human-made object in history. Launched in 1977, this aging spacecraft has ventured beyond the planets, past the heliosphere, and into the uncharted depths of interstellar space, 15 billion miles from Earth. Its mission was to explore, to send back whispers of data about the cosmos, and to carry a golden record etched with the sounds, images, and hopes of a distant world. Scientists expected its signals to fade as its power dwindled, its systems grew cold, and its journey became a quiet drift into oblivion. But in 2024, something extraordinary happened. Voyager 1, against all odds, did the impossible. It sent back signals that defied explanation, a strange rhythmic hum with no known origin, followed by a subtle but undeniable shift in its trajectory, as if guided by an unseen hand. What did Voyager encounter in the darkness? Was it a glitch in its ancient circuits, a cosmic phenomenon we've yet to understand, or something far more profound? This is the story of Voyager 1's strangest chapter yet, a tale that pushes the boundaries of science and forces us to confront the question: are we truly alone? To grasp the weight of this moment, we must return to the beginning. In 1977, NASA launched Voyager 1 and its twin, Voyager 2, from Cape Canaveral, Florida, atop Titan IE Centaur rockets. The mission was born from a rare cosmic opportunity, a planetary alignment of Jupiter, Saturn, Uranus, and Neptune that occurs only once every 176 years. This alignment allowed the spacecraft to use the gravitational pull of each planet as a slingshot, propelling them deeper into the solar system with minimal fuel. Voyager 1's primary mission was to visit Jupiter and Saturn, capturing unprecedented images and data that would rewrite our understanding of the outer planets. Its cameras revealed Jupiter's turbulent atmosphere, with the Great Red Spot, a storm larger than Earth, swirling in vivid detail. It discovered active volcanoes on Io, a moon thought to be geologically dead, and unveiled the intricate braided ringlets of Saturn, alongside the thick, hazy atmosphere of Titan, hinting at organic chemistry that could mirror Earth's primordial conditions. By 1980, Voyager 1 had completed its planetary tour and was flung northward out of the solar system's ecliptic plane, its trajectory set for the stars. In 1990, at the urging of Carl Sagan, it turned its cameras back toward Earth for one final snapshot, the iconic pale blue dot image, showing our planet as a faint speck suspended in a sunbeam, 3.7 billion miles away. That image, more than any other, captured the fragility and unity of our world. After this, Voyager's cameras were powered down to conserve energy, and it became a silent sentinel, measuring cosmic rays, magnetic fields, and plasma waves in the vast emptiness beyond our Sun's influence. Voyager 1's power comes from 3 radioisotope thermoelectric generators, which convert heat from decaying plutonium-238 into electricity. At launch, these RTGs produced 470 watts, enough to power a few light bulbs. By 2024, after 47 years, their output had dwindled to roughly 240 watts, declining by about 4 watts annually. Engineers at NASA's Jet Propulsion Laboratory, JPL, have performed miracles to keep the mission alive, shutting off non-essential systems like heaters and prioritizing instruments like the Cosmic Ray Subsystem and Plasma Wave Instrument. Each signal from Voyager takes over 22 hours to travel 15.44 billion miles to Earth, arriving so faint, measured in zeptowatts, sextillionths of a watt, that it requires the Deep Space Network's 70-meter antennas to detect it. At 160 bits per second, slower than a 1980s modem, every byte is precious, carrying data from a region no other spacecraft has reached, the interstellar medium, the sparse material between stars shaped by ancient supernovae and galactic magnetic fields. On August 25, 2012, Voyager 1 made history by crossing the heliopause, the boundary where the solar wind gives way to interstellar space. Its instruments recorded a sharp drop in solar particles and a surge in cosmic rays, confirming humanity's first direct measurements of the galaxy beyond our solar bubble. The data revealed a magnetic field stronger and differently oriented than expected, challenging models of the heliosphere's interaction with the Milky Way. For over a decade, Voyager 1 faithfully sent back these readings, painting a picture of an alien environment, sparse, cold, and shaped by forces we're only beginning to understand. Scientists anticipated that by 2025 or 2030, its power would drop too low to sustain both instruments and communications, and Voyager would fall silent, drifting forever as a monument to human ambition. But in late 2024, something changed. In the quiet hum of JPL's mission control, a team of engineers and scientists, some of whom have tended Voyager since its launch, noticed an anomaly. Buried in the routine telemetry from the plasma wave instrument was a faint rhythmic signal, a low-frequency oscillation unlike anything in NASA's records. It wasn't cosmic background radiation, solar flares, or pulsar emissions. The signal pulsed with mathematical precision, repeating in intervals that suggested structure, not chaos. At first, the team suspected a glitch. Voyager's systems, built with 1970s technology and less computing power than a modern calculator, are prone to quirks after decades of cosmic radiation and extreme cold. Diagnostics were run, and the Deep Space Network's antennas in California, Spain, and Australia confirmed the signal's consistency across multiple receptions. This was no error. Days later, an even stranger discovery emerged. Telemetry data revealed that Voyager 1 had adjusted its orientation by a fraction of a degree, a maneuver requiring precise thruster firings that no one at NASA had commanded. Voyager's attitude control system, reliant on dwindling hydrazine fuel, hadn't been used for such a purpose in years. The change was subtle but deliberate, aligning the spacecraft's dormant camera platform toward a region of space with no known stars, galaxies, or gravitational anomalies. Engineers scoured the spacecraft's programming for an explanation. Could an old command buried in its 64 kilobytes of memory have triggered unexpectedly? Logs showed no such instruction. The thrusters had fired in a coordinated pattern, as if Voyager had chosen to look at something invisible to us. The control room at JPL, a blend of modern monitors and vintage equipment maintained for Voyager's unique needs, buzzed with tension. The scent of coffee and the hum of electronics filled the air as specialists gathered, their faces lit by the glow of screens displaying the anomalous data. The signal's rhythmic hum, plotted visually, revealed geometric patterns, symmetrical intervals, and harmonic sequences that defied random noise. Cryptographers and signal processing experts were called in, comparing the patterns to known cosmic phenomena. Nothing matched. Some sequences bore an eerie resemblance to the Arecibo message, humanity's 1974 radio broadcast to the stars, raising a chilling possibility. Was something out there responding, using Voyager as a relay? The scientific community erupted into debate. Plasma physicists proposed that Voyager might have encountered a rare interstellar plasma formation, perhaps a density wave or magnetic anomaly that induced the signal and triggered a sensor response. Others suggested dark matter interactions or a space-time distortion, though no evidence supported such exotic phenomena in that region. SETI researchers, cautious but intrigued, revisited protocols for evaluating non-human signals. The patterns were too ordered, too persistent to dismiss as mere interference. Yet NASA's public statements remained guarded, describing the events as unexplained data anomalies under review. Behind closed doors, insiders admitted unease. The signal structure and the course correction suggested something more than a dying spacecraft's last gasp. As weeks passed, the anomalies grew more complex. Voyager signals began arriving with subtle modulations, variations in timing and frequency that formed recursive sequences. AI algorithms detected patterns reminiscent of binary logic, as if the spacecraft were engaged in a dialogue. Some speculated that Voyager's own transmissions were being echoed back, altered in ways that suggested mimicry or response. The idea of two-way communication, initiated by a probe launched when disco ruled the airwaves, sent ripples through the scientific world. Universities and observatories joined the effort, analyzing public data releases with machine learning and statistical models. One controversial paper claimed the signal patterns shared mathematical properties with the golden records encodings, fueling speculation of a cosmic reply. As weeks passed, the anomalies grew more complex. Voyager signals began arriving with subtle modulations, variations in timing and frequency that formed recursive sequences. AI algorithms detected patterns reminiscent of binary logic, as if the spacecraft were engaged in a dialogue. Some speculated that Voyager's own transmissions were being echoed back, altered in ways that suggested mimicry or response. The idea of two-way communication, initiated by a probe launched when disco ruled the airwaves, sent ripples through the scientific world. Universities and observatories joined the effort, analyzing public data releases with machine learning and statistical models. One controversial paper claimed the signal patterns shared mathematical properties with the golden records encodings, fueling speculation of a cosmic reply. At JPL, the Voyager team faced a dilemma. The spacecraft's power is projected to last until around 2026, when it may no longer sustain its instruments. Should they prioritize studying the anomaly or preserve resources for routine data collection? Every thruster firing and data burst consumes precious energy, and the team knows time is running out. Yet the mystery demands answers. What caused the hum? Why did Voyager turn? Is it reacting to a natural phenomenon, a malfunction, or something else entirely? The possibility of contact, however remote, has reignited debates about humanity's readiness to encounter the unknown. If Voyager has found something, it's not just a scientific breakthrough, it's a moment that could redefine our place in the universe. Voyager 1 was never meant to last this long. Designed for a 5-year mission, it has outlived its creators, its technology a relic of a bygone era. Yet it continues to teach us, not just about the cosmos, but about ourselves. Its discoveries, Jupiter's volcanoes, Saturn's rings, the interstellar medium, have reshaped science. The pale blue dot reminded us of our shared fragility. Now, its strange signals and unexpected turn challenge us to confront the unknown with courage and curiosity. Whether this is a glitch, a natural phenomenon, or something more, Voyager 1 has done what it was built to do, push the boundaries of what we believe is possible. As the signals grow fainter and the mystery deepens, we're left with questions that echo across 15 billion miles. What did Voyager find in the darkness? Is it calling out to us, or is something calling back? This tiny spacecraft, a testament to human ingenuity, may have stumbled upon the edge of something vast, something that watches, listens, or waits. The answers may lie beyond our reach, but the questions alone are enough to stir the soul. Voyager 1, humanity's farthest explorer, has sent us a message, and it's up to us to decide what it means. What do you think? Has Voyager 1 encountered something beyond our understanding, or is this a final quirk of an aging machine? Share your thoughts in the comments. And if this mystery has left you wondering about the cosmos, hit that subscribe button and share this story with someone who dreams of the stars. Because out there, in the vast silence, Voyager may first have found something that changes everything, or perhaps, something has found us.